welcome to Software Engineering Mix Volume 2. So this is the second instance. We actually had one last year. And you're actually not going to see what I'm going to present. So, yeah, so it's going to be any second. Okay, so welcome to Software Engineering Mix. Thank you so much for coming. Just to give you some idea of what we have planned for today. So basically, for Software Engineering Mix, the idea is to connect people, to bring people together to talk about software engineering. And specifically, we want to connect people from academia with Microsoft engineers, because like we had the past few days, we had faculty summit, lots of fantastic software engineering researchers came to Seattle to learn about Microsoft and about the latest research trends. And we want to use this opportunity to basically have them also meet our great software engineers at Microsoft. So essentially to connect academia with practice. And also one of the goals is to make academics aware of the real problems of today's software development and also to potentially brainstorm practical solutions. So last year we had a very general software engineering mix with a very wide range of topics. And this year we are going actually to be a bit more focused specifically on open source and also the analysis of large-scale software repositories. So what we have planned for you is, so this is our track listing for today. So we're right now in the welcome track. We're going to have 3 presentations after this. And these are basically meant to set the stage for what's going to come later on during the day. We're going to have a speed dating session. So the idea is that you're going to see some chairs in feedback. So we're going to move to feedback and we're going to interact with each other in like very quick 5 minutes slots, where basically people get to talk to each other, to learn about each other's interests, each other's problems in doing software development. Then we're going to have a quick break, presentations. We're going to do group brainstorming in the afternoon, so after lunch, and we're also going to take a group picture. And then we have, after the group brainstorming session, we have actually a showcase of some really great open source projects, which is also going to be in the back. So you already see some of the demonstrations. And that's actually all I had to say. So please enjoy the day, talk to each other, talk to people who you don't know, and learn about today's software engineering problems. And so the first presentation will be given by Judith Bishop, who's actually in charge of the Microsoft Research open source programs. And she has to tell you, Microsoft Research open source programs, and she has to tell you lots of great things about what we do with open source here.
Right, good morning everyone. I'm delighted to be the first speaker, largely because I have to fly off to Russia this morning. So I'm really sorry I'm not going to be here for all the fantastic tracks that Tom's planned. I'll have to listen to other tracks on the plane. I'm so pleased to be able to talk to you about this topic of industrial research. For more than a year now, I've been working on what Microsoft Research is offering in terms of the open source space. And in the last few months, we've been trying to put this together with my intern over here, Arun, and we have some fantastic results, which I think will lead to some discussion. So, as we know, OSS is 2 important things. It's many things, but it's a development methodology. And when you bring that to an industrial context, that really disrupts a lot of the way that things were done in the past. So you can read those big blocks, but you can realize that this is not the way that Windows was shipped, you know, with 3-month or even more like a year type of planning. So things get done a lot faster, users are involved in what's going on, and there's a very different lifestyle inside projects which are open source. That's in the product groups, and we have included in our results, which I'll show you, some product group projects as well, not just the ones from Microsoft Research. Very early release, high modularity. These are all things that have to be taken into account. The other thing is, which is particularly important from a industrial viewpoint, is this issue of licensing. So as you know, people talk in the outside about proprietary software and free software and so on, and they generally mean proprietary is bad, free is good, and so on. This is not always the case, and the lines are never very cleanly drawn. We have here somebody who's just flown in from Red Hat, where he is an intern, and I mean, that's an incredibly popular system, but it's neither free, but it is open source, very popular, right? A great model from spawned by IBM. Now, these are some of the things that one has to take into account when you're thinking about licensing. And of course, as we know, there are many licenses. I have in my appendices, you know, all the different licenses, and I don't want to go into that. I just want to sensitize us here today that this is an issue in industrial software. And if you're an ordinary researcher saying, whoops, I'm going to open source my software, well, without direction or a thought, you could land up in the wrong place with respect to licensing. So companies and universities, I suspect as well, do apply their mind to what should be done in this regard. So much more simpler than that are the three words that I always think about for open source. And that is that you create open source, you use it, and you contribute to it. And really, if you don't have all of those three, then you don't have the whole equation. So let's move on. This is an example of a particular open source tool, Python tools, which is created here in Microsoft, and it's inserted into a non-open source tool, Visual Studio, which is one of the biggest money earners for Microsoft. That's a very interesting model. It means that you can have open source software with its license and all the licenses that go with it. I think there are about 125 of these, 150, inside something that ships for monetary gain. And that's also something one can do these days, and we do it. And that makes open sourcing much more liberal, much more attractive in many, many ways. Now, at Microsoft Research, of course, you can open source anything. This was not the case earlier. It was kind of frowned upon it, but since 2014, we've been doing a lot, and we now have some 50-plus projects on the books. Maybe that sounds like a small number. It's actually quite a big number, and it's growing every month. And the projects are aimed at academia, but also at developers, and they have life cycles, and I'm going to concentrate on that and show you some graphs. The challenges have been that because you put these projects out into repositories like GitHub and so on, often people can't find them. How do people find your projects? The only way they find your projects is that you give some paper in some breakout session with 12 people in the room at ICSI. That might not be enough to get you the exposure you need. So one needs to have somewhat of a better way of distributing information about your fantastic projects. So what we've done is we've got this portal. On the right-hand side is a picture of what the portal looks like. And the address for it is researchmicrosoft.com/open source. And from there, you get to this portal. And the idea with the portal is that we divide up the projects into 12 categories. So that if you're an educator or a researcher out there, you go first to the category you want, and then you can find as many projects up to date as you like. So this is what it might look like. There seems to be something funny in the middle there. Never mind. So, for example, for cloud computing, it would show you these are the ones we've currently got, and this is a new one. It's indicated as fresh. So, from the point of view of industry, which has a lot of these projects, as opposed to a department which might have fewer, advertising and getting them out there is an issue and something we want to do something about. Now, we then went ahead and interviewed over the past couple of months all of the owners of these projects. And we asked various questions. One of the questions was, why did you open source your project? So here are the answers. Up at the top, the graph is going up to 6 or 7 there. The first answer, the most popular, was ease of collaboration. So that meant that they initially had collaborators. Often these were interns that were going back to their universities. So it really was just a Dropbox type process. That's not a very good reason for open sourcing as such, because it means you're not taking open collaborations, but it's okay. Then preventing the project from dying, they were hoping that by putting it out there, other people would just pick it up and do something with it. But this is really just a hope in many cases. Increased trustworthiness, that's very important. If you put it out there, you think that other people will actually believe in the project, be able to read it, and so on. And then get contributions, involve the community, serve the community. These are nice words, and people believe in them, but they're not highly practical reasons. And lastly, to reproduce published results. That's quite a practical reason. There were only a couple of ones. However, there were unforeseen benefits that people remarked when we interviewed them that they discovered after they had open sourced their projects. And these were that they got improved portability from contributors. There was a couple of cases where contributors to the projects have said, you know, love your project, it doesn't run on my platform, and then actually went in there and did the port. Marvelous. I mean, that was absolutely such a great thing that happened. People added documentation. If they didn't understand things, they worked it out and then put the documentation back in GitHub. Of course, the usability, if people didn't understand things, they pointed it out, those things get fixed. And adoption, which is one of the main avenues of having your project out there in the first place. So these were all benefits that people realized afterwards rather than motivations. Now, some graphs. These are on the up axis, on the y-axis, we've got the number of contributors going small, medium, large. Numbers are not really important here, because what we're trying to indicate is that over a period of years, where years is 5, projects start out, they become evolving, they become quite stable, and then they start winding down, and they become inactive. So we discovered that projects are by no means static. What I saw of the projects last year is not what the projects look like this year. Reasons are that people move on, they change into some other job that they're doing, the project is no longer interesting, or the project becomes very exciting, and people are just using it, and so more people have piled onto the project. So what you've got here is this kind of graph of our projects that we were interviewing. However, what's interesting is that even though it is industry, many of the projects are still very small with respect to contributors, outside contributors. And small means less than 5, 2, 3, right? So it's only a couple at the top that have really made it into the big time. Now, users is very similar, but a little bit more up in that bell curve. So same x-axis there, and the users, projects have got more users, but not as many contributors. So what you can see here is that they start off with many users, and then the users sort of drop off, and the projects are then sort of deemed to be inactive. And I think that's a message we've got to take away here, is that it's not a failure of a project if it starts winding down. It's just reached the end of its life. That's how projects are. Some graphs, 2 more graphs, and then I'll be over. These are actual projects. So Orleans, which you'll be able to look at in the showcase, in the Open Source Live this afternoon, is one of the active projects at the moment. And you can see in green are the Microsoft contributors, and in blue, the non-Microsoft contributors. And you can see it's sort of from June last year, the second half of last year, and first half of this year, you know, they're tapping out together. Same numbers, pretty good, stable community. CNTK is a brand new project, and it's trying to build up its external contributors. It's got lots of internal contributors, still trying to build up its internal contributors. My MS AGL is winding down. So in a sense, one could imagine, and it's probably true, that the community is taking this project over now, because there still are external contributors. But the internal contributors are winding down. Right, I just want to advertise something. Right, in order to promote these open source things, we had this lovely challenge, and we had many students all around the world piling on, working on these projects, and 4 of them are here today, so I think we'll have them stand up. Come on. Arkon, Varun, Said, and Ida. And they won prizes for their work on these projects. So they're also going to demo their projects this afternoon and what they did. Thank you. So if any questions about the figures or the graphs, I can talk to them.
So I have a more of a reaching question. Where do you see us helping? Where do you see us helping?
Scalping?
Helping you.
Oh, yes. Oh, where is this important? When new projects in Microsoft want to go open source, they generally ask around. Sometimes they ask their colleagues, but we now have officers that they can ask. They say, you know, what should we know about open source? Tell us what we should know. Warn us about what the future is about. So these graphs can help indicate to people, you know, there is a life cycle. Don't expect that your project will always be big. Don't anticipate you'll get a great big project, but you might. So it's having this model. We're also working on a tool whereby we can pull from GitHub directly these figures. So instead of actually getting them manually, so that once the project is launched, we can track what's going on. And these figures can be given to the person for that purpose. So it's an interesting question. Is the tool and the model for management, or is it for the project owner? And eventually we decided for both, because both are equally and legitimately interested in what's going on in the open source arena. Thanks. Jeff.
So hey, I'm Jeff McAffer, and this is Ryan Farr. We're going to talk to you a bit about GitHub Insights and the work we've been doing. We both work in the Open Source Programs Office here at Microsoft. And for Microsoft folks in the room, who knew that there was an Open Source Programs Office? Come on. Okay, good. So we're a body that started about a year ago to help drive and promote open source engagement within the company. So we got a big company, lots of software developers, 60,000 of us or so, and we all should be doing open source. So as you can imagine, that presents a bit of a problem when you sort of unleash 60,000 eager devs onto the open source community. They don't necessarily know how to behave. They can overwhelm people. They can not take advantage of things or do it wrong. So our goal is to try to help people do it right. And one way to deal with that is to get data, to actually understand what's going on in open source. What are we doing? What are other people doing? And Judith's answer to the earlier question was a perfect segue, because the kind of thing that wouldn't it be great when you want to go and use some open source project to be able to tell, is it healthy? What life cycle stage is it in? Are there more, like, who are the contributors? Is it my competitor? Is it diverse? Is it all just a single company? So, who knows Consumer Reports, right? Consumer Reports, you want to buy a truck, okay? So this is, I want to buy a car or a truck. I go to Consumer Reports and I get all this detail about, what other people have experienced with it. Is it new? Does it have bugs? All that sort of stuff. And it inspires confidence in your choice of choosing this truck or that truck or this car or whatever. So imagine that we had this kind of dashboard for open source projects. Both our own, you think Ford cares about what, Consumer Reports says? Probably. They go and they say, hey, look at this. Why is durability way down here at poor in 2016? We've got to do some work to make that better. So we care about the sort of quality of our open source project engagement as the ones that we produce, but we also care when we're going to go and say, hey, Windows is going to take a dependency on this open source project. We care what the nature of that project is. So that's one small aspect of the kind of thing that we're trying to tackle. Just some examples here of different health metrics. And this talk is not about health metrics. I'm just laying the groundwork. How open is a project? Where are the committers coming from? How many comments are there? All that sort of thing. And one of the example mechanisms you can use is actually, let me see if I can do this. Hey, it's going to work. Awesome. So this is GHTorrent. That's not GHTorrent. That's my shopping. Who GHTorrent users? Okay, so who's actually using GHTorrent? Okay, cool. So for those of you who don't know what GHTorrent is, it's a project run by Georgios Gousios at, he moved universities. He's in the Netherlands. And it's basically pulling all of the data out of GitHub, all the activity that happens on GitHub. You do a pull request, you do a file and issue, you do a push or a merge. All of those things trigger events, and Ryan will tell you about that in a minute. But all of that data is being pulled into GHTorrent, and now you have basically a complete history of all of the projects for all of GitHub since 2012. Right? And that's a super rich data source for looking at behavior of communities, behavior of code, nature of code, et cetera. So one of the things that he put up, you can see the URL here is, this is actually live, ghtorrent.org. And you can go in here and type in your favorite project. I like TypeScript, so I'm going to use TypeScript. And it's not just because I work at Microsoft. So this is an analysis of various aspects of TypeScript, the TypeScript community. So for example, pull request backlog, right? So somebody's done a pull request, how long is it until it gets handled? Who's doing it? That's kind of what's in this report. So you can see here that the number of new and closed is the sort of, I guess it looks pink for you. Green is new and left open. So those are ones that are just came in and we haven't processed them yet. New and closed is great because they're new by some definition of time, and they've already been closed. So that's really awesome. And the blue is less good because those are, blue is old and closed. We're missing old and still open, but anyway. Pull request lifelines, these are the 10% longest open pull requests, right? And so you can look at projects for these, the 10% longest one, the cutoff point is 25 days. So anything older than 25 days fits into this 10%. And you can start seeing like, well, some of them have been open a really, really long time. You can imagine this being a live tool where you could click on that and say, what the heck, why is that one open for 4 years? Like, what's going on with that? And click into it. This one's a static view. Where are commits coming from? So community versus the project. Oh, and this one is actually, sorry, is it coming in through a pull request or a direct commit into the repo, a direct push? Look at where commits are coming from, right? So as a percentage coming from the community versus from the actual committers themselves. Again, comments, are they coming from the community or the project itself? And then forking. So this is kind of interesting here. You can see that who knows what happened on this day? What happens in about March, April every year in a Microsoft context? The Build conference, right? So Build conference happened, somebody stood up on a stage and talked about TypeScript, and everybody in the audience went and forked it, thinking, I'm going to go and do some cool things. And we can see, whether or not that actually happened. Right? C'est la vie. That was for the Montreal crowd. So anyway, back to the slides. And so that's, the next slides are just those in screenshots in case the internet wasn't working. You can do things, now what's interesting, you start crossing this with different data sets. So geolocation. In GitHub, you're able to say where you live to some degree of accuracy. And so you can start seeing that, hey, you know what? Where it's cold, people do more work. Where it's warm, they don't. So that's interesting. They also cross that, other people have crossed that with, well, all sorts of data that I won't mention. But the other thing we're looking at doing, I was mentioning earlier to some people at the table, was crossing this with like Travis build output, right? So you can start seeing things like Bob is really quick to answer pull take up issues, open pull requests, put them in, and they get built, and you take it all the way through build and see that the builds usually pass, and they don't have any test failures. Fred, on the other hand, is a little sketchy, and he takes a long time to do stuff, and he typically ends up with build errors and test failures, right? So you can start understanding the nature of community by harvesting all this data together. Oh, look at that, Office is going to update. I think I'll postpone. Okay. So these are the kinds of insights that I was talking about. Judith's point about scale, like when we start scaling up Microsoft to use open source, we really have to understand all these different aspects and how important it is from a sort of industrial point of view. It's not just about project health though. Things like product adoption, right? We can go and look at all the GitHub repos and understand, are people using VS Code? Who uses VS Code? See, now if I knew your projects, I wouldn't have had to ask you. I could have just gone and looked at the GHTorrent data and seen that you have a .vs code folder in your repo, right? Same thing with Visual Studio or different languages. APIs, are you using the Azure SDKs? What APIs are you using from those SDKs? Are you using them right? Are you using ones we didn't know about? If I want to change one, can I go and change it and not break people? That sort of thing. Those are all really cool and interesting from a company point of view, from a sort of industrial point of view. Research, I mean, I'm speaking to the choir here. Lots and lots of different things you can do with this data from like a software engineering point of view, branching and pull request behavior, code flow, that kind of stuff. We've seen collaboration people looking at collaboration characteristics and that sort of stuff. Yeah, when you start mixing it with different kinds of data like I showed with the geo stuff, you can also look at, we did recently some mixing with climate data, as you saw there. But you can also start bringing in things like Stack Overflow questions, build results, like I mentioned earlier, customer satisfaction for whatever metric that is, sentiment analysis over Slack or Twitter or whatever. Get you a more holistic view of what's going on in a set of projects. And then finally, operational insights. And this is Ryan's domain.
All right. Thank you.
I'm gonna stand
Okay.
here.
Yeah, so we can also do a lot of operational insights. So we can look at repository management, user management. We can look at who assigned CLAs and stuff like that. But what's more important for the stuff that I'm doing this summer is the fact that you can do more than just analytics with it. You can actually use it to, in my case, make sure that everybody is following open source policies. So I've kind of set up Microsoft's GitHub torrent, which tracks the public and private Microsoft data. And with it, I've been creating bots, which we call cops, that really just do exactly that. They make sure that everybody is following Microsoft's open source policies. If you don't have a license in your repository, you'll probably get an email from one of my bots soon and an automatic pull request, stuff like that. But how do we actually get this data? Well, as Jeff mentioned before, actually, let's look at the numbers first. So there are about 15 million users, 38 million repositories, something like half of which are private, and about 1 million events per day. But as Jeff mentioned before, we use GHTorrent, and as you can guess, Microsoft GitHub Torrent is based on GHTorrent. It's just like slightly tweaked by adding webhooks and stuff like that. So GHTorrent just gathers all of the public data and archives it. It tries to completely capture all of the entities and how they're related. And then it enables people to do a lot of really interesting analytics, but also create bots, as I mentioned before. So how does it work? Well, it uses primarily the Events API, GitHub's Event API. In Microsoft GitHub Torrent, we also use webhooks to get a live stream of data. And for each event, which I'll just show you the event stream right now, if it'll work. Well,
Control click.
Yeah. Okay. All right, there we go. Yeah, so if we go to api.github.com/events, we can see that there's just a whole bunch of JSON here. It looks maybe even a little bit meaningless, but we can see that there's a type. It's a pull request review comment. Okay. So let's look at the actor. Let's go to their URL. Okay. So what other repos are they working on? Nothing, apparently. Let's look at what they have starred. Nothing. All right, well, it's usually more interesting than that.
So this is live data, right? So just
Yeah.
at the time we got that, we got whatever data you get.
Yeah.
But the interesting point there is that you get to pull you basically get this graph of data that you get to pull on, right? You get these events that you can see everything that's going on. And
Yeah, and exactly. So what I was just doing is almost exactly what GHTorrent does. It just grabs something from the event stream and then recursively walks the JSON. It just looks at all of the other links. And then periodically behind the scenes, it will go back and use the Events API to make sure that all of the data is up to date in case there are any events that we can't get through the event stream, something like that. So here's an example, just as I showed you before, but the internet worked, so we're good. So this tries to collect a ton of entities, really everything that it possibly can: org members, pull requests, commits, events, followers, users, watchers, so on and so forth. Just everything you could possibly want. How it works is that on the right side here, you can see the event retrieval. It's just a script that really uses the Events API to periodically pull from the event stream on GitHub, and then it will add that to a database, and it will split it up and add it to RabbitMQ event queues. And on the other side of that, there are these data retrieval processes running that look at these events, and those are what go down the rabbit hole and recursively walk that JSON. They pull everything they can off of GitHub using the GitHub API again, and then they add it to a different database, this time MongoDB. So GHTorrent, in its vanilla version, has data all the way back to February of 2012. It has something like 5 billion event rows in MySQL and 10 terabytes of MongoDB data, growing by about 10 gigs per day. So we have a ton of data. And I'll just leave it to Jeff to talk about how you can use that data.
sure. So one of our goals, in addition to getting all these insights for ourselves, is to enable you and everybody else to gain the insights you want to have. So there are multiple ways that you can actually get access to this data. One is hosted. I showed you already, we went to ghtorrent.org. You can go there and you can run some queries on MongoDB and MySQL hosted on the machines in, well, wherever Georgios has them. Actually, they're probably running in our subscription of Azure data, Azure subscription that's hosting ghtorrent. But you can go there. That's great for poking around and understanding what's going on. They tend to be, they're rate limited, right? You only get so much compute, and it's basically, I think the queries are 100 seconds or something like that. They're limited to 100 seconds. Oh, it says it on the screen. So that's good. You can go and poke around and see what the data's like. But you want to do something substantial, right? You're doing your research or whatever, and you want to do 24/7 queries over all the data. So you can actually go and download the data. Right? The ghtorrent has a place where you can go and grab the dumps of the databases. So you can grab that dump, reconstitute it on your machines, and then do party on and do what you want. How many people have grabbed those dumps? Anybody? Okay, was it fun? I mean, it's a little challenging. It's pretty large. You got to stand up your machine. Then you've got the challenge of keeping it up to date. There are daily dumps and that sort of thing. But it's a bit of a, it's a bit of an overhead. Oh yes, right. So instead of doing that, you can install and install ghtorrent on your machine. It's open source software. It's on GitHub. And this is what we've done for our private repos. So Ryan mentioned MSGHT or Microsoft ghtorrent. That's an instance that we run to gather all of our data from our public repos and our private repos, because ghtorrent has only public data. So you can go and stand up all this yourself and get it harvesting a set of repos that you have access to, whether they're public or private. And that's really cool. That works really well. You've got to get a set of API keys so that you don't get rate limited by GitHub. And it's a fair bit more overhead, but it's actually really cool if you're wanting to monitor private repos especially. What we've been doing is trying to take all that data and make it available to you easily. So we've got this thing called Azure Data Lake, which is a new service being offered by the Azure team that basically has storage and compute. Okay, so it's a big data solution, so we can dump terabytes and petabytes of data into storage, and then you can spin up compute clusters or analysis clusters to go and work on it. And so our model here is we're managing the storage. We'll keep that data up to date in a shared storage place, and then you can come up with a compute cluster and say, hey, I'd like to go and do these queries on that data. And for us, we're maintaining the data anyway, so we're just making it available to you. And for you, you can query as much as you want. Right now, it's USQL is the query language. It's a data lake, a new data lake query language. But we're also, Hadoop and Spark we haven't actually done it, but the theory is that it works. But if it doesn't work, we're going to make that happen. So the idea then is you just contact us, we hook you up with the data, and then you set up your compute cluster. Right now, it's a copy. The sharing structure in Data Lake isn't working 100% to what we need. So you end up getting a copy of the data, and there's simple scripts to do it. You let it run for a couple hours, and you end up with your own copy of the data. And then you can compute on that. In the future, you'll just hook your compute to our data and share it. And that is it. So if you want to know more about the GH Insights work, there's a GitHub repo with some instructions and that sort of thing. Anyway, any questions? Yeah.
So to start using this data, we contact you?
Yeah, the instructions are actually in the repo, but feel free to contact me. Yeah. Okay, thanks very much.
Oh, I think he actually has a
sorry.
question.
Yeah, I just wanted to know if GitHub is aware of.
Absolutely. So there are other solutions. GitHub Archive, anybody know about GitHub Archive as well? So it's something that was run by Google, and Google just came out with a new mechanism. They put all their data into BigQuery and Bigtable and that sort of thing. So we work with the GitHub guys, and we've had some various discussions about how to make this easier and better, and how to enable this data to be more readily available from GitHub proper. Those sorts of things. That's still in discussion. But we're not taking, at the end, this is all public data. So we're not doing anything against their terms of use or whatever. And we do obfuscate email addresses, by the way. So earlier it wasn't being done, and there were a few people who got, by the way, researchers, one of the things that we get complaints about, because we've aggregated this data, is researchers taking it, getting the data and sending emails to people saying, hey, would you like to take this survey? I see that you're doing, Python. That's actually not allowed by GitHub. That's against the GitHub terms of use, and it's something that we get a lot of flack about in managing things like GHTorrent. So don't do that, please. Yeah?
So do you think that you're going to have researchers providing their own insights, their own mechanisms that are also going to be incorporated into it?
That's a great question. So basically this should be recursive. My ideal for this is that there's a community of researchers and other people who are developing cool queries. And if there's some cool query that everybody wants to know the answer to, super popular, right? And imagine these all go into GitHub repos and you contribute your query and I contribute mine and so forth, and people keep running yours. We'll just run it all the time and have it available in the shared data set so people don't have to. This is the ideal, right? That'd be fantastic. That would be super success if we were able to get to that point. Okay, thank you very much. Have a great day.
Thanks, everyone. I'm Nagappan, and this is some work that I did with some of my students in RIT, Nuthan, Steve, and Craig. It started off as a class project, but they ended up being my master's students, and Nuthan's another PhD student, and we carried on with this work afterwards. When I got the email to talk at this forum, I was thinking, why is this topic interesting today? Like, why is this interesting today and not in 2006 when I started my PhD? Is A, there's a lot more access to data today than 10 years ago, right? We have, at that time, I think there was SourceForge and a few projects in Apache, but now we have GitHub, we have the Android App Store, which I personally mine, and I get like tens of thousands of apps every day from Google, and they kind of just turn a blind eye towards us and not actually tell us anything. But we get that data every day, right? And there's so much data that we have that when I started my postdoc in 2011, the servers had 2 terabytes of storage, and nobody was using most of it. But when I was finishing it up in 2014, we had used up almost 12 terabytes in the servers. Right? So that's how much data there is available today. And as we heard yesterday and day before yesterday, there's also compute power now, right? There's Azure and there's other AWS and other services where you can go and analyze these large sets of repositories in reasonably okay times. So we've done studies where it took us only 24 hours to analyze about 800,000 repositories. So it's not too bad, but it's still doable. So I think these are the 2 factors why analyzing these large sets of repositories from GitHub or any other set of repositories is becoming popular among the research community. At least I think so. But the other reason is, what can we do with this data? And I think Vladimir is going to talk a little bit more about this later, but I think they can have a data-driven decision support for the different stakeholders in different stakeholders, right? Like, you can use the large set of repositories to answer questions for developers or maintainers or managers or build engineers. And as like I said, Vladimir is going to talk a little bit more, but I just wanted to give a couple of examples to set the context. Baishakhi and her colleagues had this paper in FSC 2013, I think, on whether you should be using static typing or dynamic typing. It was a very controversial paper as well. And they used 700 repositories. Like, before that, there weren't many studies that used that many repositories to answer these kind of questions, right? There's another study from Fang Zhang who tried to build a universal prediction model by building a defect prediction model not on one data set, but on 1,300 repositories together. So managers can now use this model to find out how to predict bugs for their repository. Bogdan had this other paper on whether continuous integration was good, and it was a little bit more. Now we're doubling. It was almost 1,800 repositories that was used. And a study that Shane and Bram and some of my colleagues in Queens, we used 170,000 repositories to find out what was the relationship between build maintenance and build technologies. And one of the things that we found out in this study was, technologies like Make, even though seem more difficult, had considerably lower maintenance effort than easier technologies like Ant or Maven. And there were several reasons for it. One being that because it was easy, people were more ready to go and churn those files, whereas Make was considered difficult, so people didn't want to really go and touch those files. Also, Ant and Maven did other things as well beyond just build support. And the final example that I wanted to give was a study that I was personally involved with very closely. It always bothered me that Dijkstra's study, while good, had no empirical evidence. Like, was our go-tos actually bad, right? And so we wanted to explore this. So we looked at about 11,000 C projects in GitHub, and we wanted to see, are they actually using go-tos anymore? And we found out, yes, actually about a third of the projects that we looked at had go-tos, and about 11% of the files in these projects actually had go-tos in them. So we wanted to see why they were using these go-tos. And we found out that most of the go-to use was for error handling and cleanup, like memory cleanup, because C didn't have those constructs in the language. And so most of the use was for very simple purposes. And what Dijkstra feared, like spaghetti code, right, was very, very rare. Not many people were using it for jumping around in their code. So because of this, what we found is that there were very few go-tos that were removed or modified in a post-release failure. It hardly had any bugs. So go-tos can be harmful, but they need not be if you use it for certain purposes. So this was something that we were able to mine tens of thousands of repositories and try to understand how people are using go-tos and how people can use go-tos. So this was a recommendation we can give to developers on how to use go-tos. But in all these projects, there's a common underlying issue. And the issue is, what are these projects that we are studying on GitHub? When we studied 5 projects, we knew exactly what these 5 projects were. But when it goes to hundreds or thousands or tens of thousands, we can't actually go in and see what these projects are about. It becomes difficult, right? For example, in our go-to study, we took a sample of the files, and we wanted to see what these projects were about. And we found that all of these projects, or most of 90% of these projects almost, were driver code or kernel code or very low-level system code, not high-level applications at all. High-level applications were not using go-tos. So there were certain kind of developers who knew how to use go-tos, and they were using them safely. So there is a context to our study as well now, and that can often go missing when you analyze large sets of repositories. This is the best-case scenario. The worst-case scenario is that it could be a lot of noise. Imagine these projects could be student projects, right? And if you study these student projects and looked at the commit history, you might think you should be committing as a company only at 11 o'clock on a Friday night, because that's when assignments are due, right? So it could be tutorial projects. When we analyzed the Android data set, we found so many Hello World applications, because the tutorial is to create a Hello World application. And if you have a Google account, you can upload the app. There was no reason not to upload these apps, right? So it could be personal projects. It could be forked projects. So it could be projects that not necessarily means a project that we should be analyzing. But maybe we do want to analyze student projects for a particular case study. And in that case, we want to choose just the student projects, right? So how do we know something is an engineered software project or not? And in most cases, we want to be studying engineered software projects. So we want to remove the noise, and we want to look only at projects that were engineered, are actually used as a software project, right? So this is what our goal was. We wanted to see how can we find these engineered software projects in GitHub. Right now, the solution is, and in the past studies that I talked about, The solution is to use some metrics that are already available in GitHub, like stargazers, or the number of watches, or the number of forks, right? So the Facebook iOS SDK has like 5,000 stars. So it's a good proxy to say that if you have a lot of stars, then that is an engineered software project. A student project is not going to be forked by many people. A student project is not going to be watched by many people, right? So that's a good proxy. But can we do better than this proxy? Is there a better way to actually find out if something is an engineered software project? And that's what we wanted to do. We wanted to curate GitHub and find engineered software projects. We used the GHTorrent data set, and it's actually surprising how big this has grown. We used a dump from late 2014, early 2015, and it had only 2 million projects in it. And now it's grown by almost a factor of 10. Right? But before that, we need to first define what an engineered software project is. And this definition is incomplete. What we have is incomplete. I have to say that caveat. But we've tried to make sure that people can add to our definition. Right? So we define a project as engineered if it has some kind of architecture. Actually, components are talking to each other and not just standalone. The software project has some kind of community where people are talking to each other. There's a few people working together. It has continuous integration. It has some kind of documentation. It has some kind of history, that there's some prolonged history of people committing regularly to the project. It has issues. I mean, a project without issues is, I guess, not a project, right? Like, nobody is perfect in their first time, so there's going to be issues. Does it have a license? And does it have testing? Of course, this is incomplete. You can always add more to this, but these are the 8 dimensions that we came up with initially. And then we wrote, we had a reference implementation where we went and collected this information from the GitHub projects that we had in GHTorrent. And then we used these metrics, we calculated these metric values, and then we used a threshold, which I'll explain in a minute, and added some weights to make sure that there were some factors that were more important than the others. And each repository is given a score in the end. Right? To determine these thresholds, we wanted to use projects that we knew were actually engineered software projects. So we went to companies. We took GitHub projects that were released by Amazon, Apache, Facebook, Google, and Microsoft. I'm assuming that these companies are not releasing toy projects on GitHub. Right? So we used these projects, and we measured the same 8 dimensions to see what values these dimensions had for projects that we knew were projects. Right? And we took the minimum values. So we were very safe in saying that something is an engineered software project. So according to our metrics, if the commit frequency is 2 commits a month, it would still be an engineered software project. And you'd be surprised by how many projects in GitHub don't have even that, don't have 2 commits a month, does not have 0.1% of test cases in the source code, right? Like, very low thresholds, and still a lot of projects did not cross these thresholds. So by using these, we were able to look at the repositories and score these repositories. And as an example, we have this repository here called Premailer, which turns CSS blocks into style attributes. And it has a lot of stars. It has about 576 stars. So our old metric, by using stars, would have said that this is an engineered software project. And our method also said this was an engineered software project. It had a perfect score of 100. But there were some interesting repositories that we found out. For example, this project called Retaliation had a lot of stars. It had about 459 stars. But the whole project was one Python file. And all this did was, if someone broke the build, it fires off like a foam rocket from a USB port, and it goes and hits them. And that's all it did. So it's a cool project. So a lot of people wanted to use it, but there's hardly any commits to it. There's no issues in it. And it was just a toy project, right? So we really can't learn much from this as an engineered software project. But look at the other side of it is this project called Yard T Receiver, which is an actual project, I think, because it has a lot of commits, it has a lot of contributors, it has issues, there's actually communication, and the purpose is to execute a Yard T shell. But if you look at the number of stars, it has only 1 star. So we would not pick this project up in our old analysis. And because of that, we won't be able to analyze projects like this. We'll be missing out very interesting projects. Right? But we can't just give anecdotal evidence and say that our approach is great, right? So we wanted to still evaluate it. So we had to go in and collect some ground truth data. So we took a sample, a statistically valid sample of 384 projects, and we manually classified them as projects or not projects, not engineered software projects or not engineered software projects. And we didn't use any of the dimensions. We didn't use any of the metrics that we calculated. We just used the documentation that was there in the project. We read through the documentation, the README files and the purpose and all of those things to classify if a project is actually an engineered software project or not. And based on this, we found out that our approach has about 75% precision. So about 25% of the times we say something is engineered and it's not. And I think it's because of the low thresholds that we have. We classify, there can be a group of 4 students who are working together diligently on a project, and we could classify that as an engineered software project. So it is possible. And we also had a recall of about 67%, which means that we were missing some which could have been projects. But again, this could have been a very good student project that when we classified it, we could have thought this is definitely a project when it may not have been. When we compared this against the Stargazer's approach, we found out that precision was 100%. So every time a project had a lot of Stargazers, it was definitely a project in our sample. But recall is 0.69%. It's not 69%, it's 0.69%. So we are missing out 99.3% of interesting projects, right? We're looking at a very small sample when we are making these decisions about what engineers should be doing. A vast majority of it we're not including. So I think that this is going to become an issue because we're only considering projects from Apache and Google and all of these big companies, but not the smaller things. There was another example of a Ruby project which had 10 stars. So much discussion, and it is a very important project, but it wouldn't get chosen, right? So we could have learned something from that we are now missing. Oh, so yeah, that's the results. So we wanted to make sure that other researchers have access to all of this as well. So all our analysis on the 2 million repositories that we did is available. So if you go to that website, you have the paper, the data that you can download, all the individual dimension values, the scores, and the links to the repositories. We actually got contacted by a researcher from NC State who wanted to find out all projects that had test code alone. So they could avoid all the other dimensions and only pick the testing dimension and pick projects for that, right? So, and you can have your own scoring mechanism because we've given you the raw data, and you can pick projects based on that. We also wanted to make sure that if you wanted to add another dimension, it was going to be easy. So we released the source code as well. And all that you have to do if you come up with a new dimension is to just add a script that calculates that metric and 3 lines of code in our main file, and that's it. You're all set to calculate new values as well. So with that, I'll stop.
Sorting out all the non-projects from the real projects is super useful. If I want to run this, is this based on current data?
Yep.
MySQL code or?
MySQL code.
Okay.
Yeah. And if you look at it's in quite small font up there, but out of the 2.2 million projects, what we think are engineered is only about 250,000. Right? I mean, there could be others as well, but we think only about 250,000 of them are engineered software projects, the rest are not. There were some dimensions for which we had to actually get the repository, get the code, which GH.Torrent didn't have. But we had the links, so we got it, and then we calculated those.
So are you able to filter, like, is this data queryable?
Yeah. So if you actually go to the website, we have a CSV file. So you can download the whole CSV file with the links and everything. And then you can query it.
Okay, like the actual data.
Yeah, so this, whatever you can see here is available as just an Excel file, a CSV file for you to download.
But can I somehow curate that before I even get the CSV file? Because I want to get
The CSV file is not big. It's about 10 megabytes.
Okay.
So it's only 2.2 million rows, right? So it's not very big. It's a pretty small data set.
And the second question I have for you, real quick. So it still doesn't fully solve the question of context, because although you do get engineered projects.
Yes. It doesn't solve the problem of context.
Yeah.
So we did some work. I did some work with Tom and Chris a few years back, which we published in FSC then, where we wanted to see diversity of projects. So this is the first step, right? After you get engineered software projects, then you can partition these projects into different bins and try to do analysis on all the bins and get some context there. You want some projects which has a lot of commit history, not a lot of commit history, 1,000 developers, maybe 10 developers. So you can still split it based on these metrics and get a little bit more context, but you still don't have the domain context. That is still missing. Each is a project. Each is a project, not a repo. Is each of it a project or a repo?
I mean, the only thing I wanted to check was sometimes multiple repos are a project, right? You cannot always say each repo is a project. A project would be multiple.
Yes, so this is each repo. Each repo. Yes, Jeff.
Real quick, is this updated regularly or just?
Not regularly, because we, as regularly as we can get GHStar and data set. So that was why I was asking if we can
so
kind
it would be really cool to recast these queries as,
Yeah.
in our case, use SQL things, and then we just run these all the time and
Yeah.
be live and available.
Yeah.
Having 15 million repos is really cool, but people really just want to compute and research and study important ones. Or
Yes.
interesting ones, and
Yes.
having that data set and narrowing it down would be really awesome.
Yeah, exactly. That's the goal, right? That's the goal. And so we haven't updated it since we've done one update. So the first try that we did, it had about 1 million repositories. The second dump that we had, it had about 2 million repositories. But it's still quite old. It's just a year and a half old, but it's still old now. Okay. Thank you.
Okay. Okay, so I forgot actually one thing in the introduction, which was to mention our organizer team. So it's not just me who organized it, it's actually Andy Bagel, who was in the back, Chris Bird, also in the back, Judith Bishop also helped us organize, Trevor, also here, Trevor, and Hongyu Chang from MSR Asia. He unfortunately cannot be here today. Okay. Well.